Hello, everyone. It's my great pleasure to give a talk in this platform. I hope all of you have some idea about renewable energy, how it can help to mitigate climate change and safeguard the future energy demand. In this presentation, I will talk about potential environmental impact of solar and wind energy and how to mitigate those impact. Let's proceed. In this slide, just give an overall idea about electricity production by source in the world. Before describing this figure, let's have a look what are the electric generation units used for. So if you look at the left side, there's a say that 1 kilowatt hour. What it means is electricity generated or used for 1 hour. And all these units we will use later to describe the production and of the electricity, and we need those information. 1 megawatt equivalent to 1000 kilowatt. Similarly, 1 megawatt hour equivalent to 1000 kilowatt hour. And that will go slowly up to 1 terawatt hour equivalent to 1000 gigawatt hour. Let's describe the now the figure. In this figure, in the left side, it's showing that global electric production by terawatt hour, and the right side is showing that the different production segment, that's the what energy are using to produce that electricity, and in the bottom it's showing that the trend of electric production from 1985 to 2021. In 2021, global electric production was 27,520 terawatt hour, of which 61% of the electricity are generated from fossil fuel like oil, gas, and coal. In the next figure, let's have a close look to see how those different components are contributing to the electric generation. In the left side, the fossil fuel 61% and nuclear, hydro, wind, and solar producing 35% and other energy rest. And in the right side is give you more details of sector-wise production. In the for example, coal is producing 35% of world electric generation. Gas followed by gas is 23%, and then hydro 16%, nuclear 10%, wind 5.9%, and solar 3.2%, and rest all other energy sources that contribute production. So based on the different study, it's revealed that global energy demand expected to increase 35% by 2030. That means in future, we need more than 1/3 of current requirement energy for our use. So we need more energy. This energy, let's start from the world perspective, get some idea. Now start from world to back to Alberta, how Alberta doing in energy production. In Alberta, as of 2019, fossil fuel contribute almost 90% of total electric demand. However, this dependency is reducing, but slowly. Currently, it's around 88 to 87 to 88 or 89% are producing from fossil fuel and rest from wind, hydro, biomass, etc. Coal contributing in Alberta is 5.5 gigawatt and the largest in Canada. Solar and wind only contribute 1.9 gigawatt. So compared to prospects, very less amount. So let's have a look about what are the possible impact of conventional or fossil fuel based energy system. Fossil fuel based energy is the major source of greenhouse gas emission. If you look at the tables, it shows the three energy systems that mostly used in Alberta or across the world: coal, oil, and gas. It produces greenhouse gas like carbon dioxide, coal producing for 1 kilowatt hour, it produces 994 to 1130 gram of carbon dioxide and 4 to 4.71% of sulfur dioxide and 2 gram of nitrous oxide and particles. Similarly, well, little less, 758 gram of carbon dioxide for per kilowatt hour energy production and the gas. So it's contributing a lot of greenhouse gas emission directly linked with emission for the conventional energy. So coal contribute 35% of world electric generation and emitted 72.5% of carbon dioxide that is related to the electric generation source. In USA, fossil fuel contributes 63% of electricity and emit 28% of its carbon emission. And USA is the second largest country in the world that contributing the carbon dioxide. In Canada, emission from electricity declined 43% between 2000 to 2017. But in Alberta, electric generation emitted 16% of greenhouse gas or 60% of total Canadian emission from power sector. That means Alberta is the highest, almost 60%, producing 60% of greenhouse gas because of extreme dependency on conventional energy system. Now, to depends on this this impact of conventional energy system, how it's can impacting on overall our environment. The emission lead to increase the climate extreme event. For example, increase the annual temperature in Canada. Based on the data and model prediction, it shows that if is the high emission rate, Canadian temperature can raise up to 6 centigrade temp, and if in a low emission, it's 1.5 centigrade. There is a possibility the average yearly temperature will be go up by 2100. Then another issue is flooding. This flooding can cause because of the this climate extreme events. Some part will get a lot of rainfall, and other will get less rainfall. So that's the flood is happened in BC, and suddenly a lot of rain causes this flooding. Then comes forest fire. So you all already get some idea about and know about that how the forest fire in contributing in the last few years across the Canada, and most importantly in Alberta in 2016, big Fort Mac forest fire. So that's raised a lot of question about how to or why that's happening nowadays more frequently. And another issue is the drought. As I say that some area will see a lot of rainfall and other will see less rainfall. So therefore some area get a rain and some will not get rain, and that will directly cause the drought and impact on agriculture production and other farming activities. Then another event is cyclone or tornado. So that's the extreme sudden cyclone and tornado can occur across the country and across the globe. So that increase because of this greenhouse gas emissions increasement. And another one is the sea level rise. The sea level is expected to increase by 50 centimeter and some more by the 2100. And if that's happened, many low the countries that are near in sea level like Netherlands, Maldives will go under the water. So there's the possible environmental impact. If we switch from conventional energy to renewable energy, how it can help us. So move from carbon intensive conventional energy to renewable energy can help to mitigate climate change, safeguard energy security that we will explain and we will get some more information in next few slides, and increase the sustainability of human activities. For greenhouse gas, how it's helping for mitigating climate change. Let's have a look the greenhouse gas emission from this solar and wind energy. If you look at the solar energy, that's only 14 to 38 gram of carbon dioxide emission per kilowatt hour electric generation, and rest is there's nothing, and mostly this is producing during the production of solar panel, and where this wind does not have any contribution of greenhouse gas emission. Then here's another figure showing that how renewable energy can impacting on carbon dioxide production or reduction. So in the left side, it says that carbon dioxide emission avoided, that means metric tons, and the right side it's showing that car equivalent of carbon dioxide emission avoided. In USA, impact this USA based on the wind energy production that shows that from 2001 to 2017 the carbon dioxide emission reduced 189 million cubic metric ton of carbon dioxide, and which is equivalent to taking off 40 millions of cars from the street. So now think about what is the renewable energy's potential, how much renewable energy we can produce. So let's, in this figure, it shows that the global energy potential for solar is 6.5 million gigawatt, and whereas wind energy is 1.7 million gigawatt. And if you look at the figure, it shows that the energy resource of the world, that's the solar energy, can produce 2,850 times the of electricity that's currently we are producing. That means as it's I say that currently it was 27,520 terawatt hour, so it would be 2,850 times. Similarly, wind energy can produce 200 times. So this indicates that these two energy resource can provide enormous amount of energy for the world, and the whole world ends. So there's no lacking of these resources. So production as of 20, total 29% of global electricity, of which 10% from solar and wind energy. Solar contribute 501 gigawatt and wind is contributing 743 gigawatt of electricity. So globally, 82% of all new electric generation generating in 2020 came from the renewable energy source. This is another indication of that the world is moving from conventional energy to renewable energy sector, and therefore people are more investing on renewable energy, and that has the enormous amount out there. From the world prospect, let's back to again Canada. So solar and wind energy in Canada. Canada is ranked 9th in solar energy and producing 3.1 gigawatt, and 8th in wind energy and producing 13.6 gigawatt. And in Canada, 7% of total electric supply coming from wind and solar energy. That is less, and still we have to work hard to increase that percentage. From Canada, come back, let's start talk about Alberta. How is Alberta doing in terms of renewable energy? In Alberta, solar energy producing only 0.1 gigawatt. That is offset almost 50,000 ton of carbon dioxide per year. And it is expected that by 2020, the solar energy production will increase to 1.8 gigawatt. Considering the wind energy, currently producing 1.8 gigawatt or 6% of total generation. And this Alberta is third in Canada, and it was expected that by 2025, the wind energy production would be 6.5 gigawatt. So after reading that, we are getting all an idea is that solar and wind energy are clean. But are solar and wind energy as clean as widely believed? Let's have a look next few slides. So first, I'm talking about solar energy. Before going in detail, just have a look how solar panel work. Sunlight hit the solar panel and generate electric current, that is DC, and the electric current flow through the inverter, which convert DC electricity to AC and most commonly used form of electricity. And the AC electricity flow inside through the inverter and to the breaker box, and which direct to the all the appliance at home. If we produce more electricity through the meter, it will go to the grid, and if we require more electricity, then we'll get from the grid. And this is the kind of simple way to explain this how solar panel works. Let's have a look what are the possible environmental impact of solar energy. First of is soil, the compaction. The compaction is occurred when the big solar farm is established. Then big the equipments are moving there, and therefore soil is getting compacted, and that has a direct negative effect on soil physical and chemical properties. Then topsoil erosion. You can see the right hand side figure that is clean all the vegetation that increase the erosion by water or wind. And that erosion can increase the sediment or turbidity in the local stream. Then comes to water. So for 860 liters of water is required for 1 megawatt hour electricity generation. Is mostly water is used for cleaning the panel and mirror and dust, because if there's a more dust, the efficiency of solar panel is goes down, and therefore it needs to clean up to keep the efficiency high level. Then emission, as I said, no emission during the operation, and panel manufacturing is 14 to 38 gram, and so 1.1 gram of mercury per gigawatt hour electric generation. Then vegetation and wildlife. So obviously establishing a big farm, vegetation loss will occur, and wildlife mortality. That's the one of the important factor, because every year in USA, 37 to 138,000 of birds killed due to the solar panel or solar farm. And another is habitat loss and fragmented. Establishing big solar farm is fragment the habitat, and that will create a barrier for wildlife movement too. Then footprint. Footprint, it means that the area required to establish a farm, or it's estimated that 8.9 to 56.3 meter square is required per kilowatt electric generation. And another issue is that conflict with other land use like agricultural land or farmland, forest lands. So when establishing this farm. Then hazardous waste, chemical compound, cadmium, selenium, lead are used for the producing the solar panel. Cadmium used as a semiconductor to convert light energy to electric energy. So that's require 5 gram of cadmium per square meter. Cadmium is very carcinogen and it can cause cancer to animals. So that's the one hazardous part. Then what are the mitigation for those? The first, soil restore sounding disturbed area for reducing the erosion and compact. So as soon as farm production start to operating, restore the site, and consider careful landscaping during plant construction that will not disturb outside of the farm area. Then water. For water issue, use the rain or other recyclable water, or need to develop alternative method to increase the cleaning efficiency. That's the researchers are working on that to find an alternative method. And plants should be nearby continuous water supply facilities, that you are not run out of water, and avoid location that impact on surface water bodies. Then vegetation and wildlife. Revegetation area between and under the row, and to reduce the bird mortality, use acoustic. This is a kind of sound create that bird avoid that area, or visual. They use the some lighting or some other stuff that birds can stay away from the solar panel. And chemosensory deterrent is a kind of chemicals used that birds irritate and stay away from the solar farm. And hazardous waste, the recycling solar panel to reduce the hazardous chemical and take proper care when disposing or cleaning the equipments or chemicals. Mitigation, avoid the footprint, avoid the ecological sensitive area and co-locate it with other energy system like coal, oil, wind and geothermal, and use landfall or abandoned mines. You can see that's in the figure 1 is the solar and wind are combined together, so you can reduce the footprint. And similarly, the mine, you reduce the footprint too. Then comes the wind energy. How the wind energy work? Let's give it one refreshing how it's work. Wind blow past turbine and rotating the blade. The kinetic energy is transformed into the mechanical energy, and a gearbox is spinning a generator and to produce electricity, and transformer convert the electricity to appropriate voltage and store it or distribute to the or send it to the grid for distribute. Then what are the environmental impact? One of the important impact is the visual is that is change the natural landscape view. That is all big high solar wind turbine can some people not like, that's the visual issue. And another one is the shadow flickering. The shadow flickering is that periodic flashing of sunlight due to the turbine blade movement. When the turbine blade is moving, sunlight reflecting on it and it can create the shadow flickering. And vegetation and wildlife, the wildlife mortality from this is also from US data is 2,000 to 234,000 birds killed every year due to the wind farm. Habitat loss, as I mentioned, wildlife movement, that's the all are similar like solar farm. And here's the one figure is showing that's the how the different factor is contributing the bird's mortality. If we look all this, still the wind turbine or wind energy cost mortality is way below than all other energy source. Then noise, creating on the wind turbine when it's moving, creating a irritating rhythmic swishing tone, and that causes this is a continuous process and it's very irritating to tolerate. The another one is the land use or footprint. Permanently less than 0.4 hectare per megawatt electric generation, and temporarily it's require 1.5 hectare per megawatt, and as I said, conflict with other land use system. Then the soil, let's talk about the mitigation. So the soil, the restore sounding disturbed area for reducing erosion and compact. As soon as the wind start to this wind and start to operating, the disturbed area should be reclaimed and restored for reducing the erosion, compactness, or vegetation. And visual mitigation, proper alignment of the wind turbine tower layout can help to reduce that visual issue. Like small number of wind turbine can create a visually balanced sample and consistent image, for example. And shadow flickering can reduced by optimizing the rotator blade surface smoothness or coating with less reflective materials. And for mitigating vegetation and wildlife, plants should be located in area less biodiversity, and improving structural design like enlarge the blade and slowing down the rotational speed of wind turbine can help to reduce the bird's mortality. Increase the visibility by using the night illuminator on the blades and limit the operation during the hours of heaviest migration, for example just after sunset or during the high insect activities. For the noise mitigation is the careful design of the blade. So still is researcher working on this to mitigate that one. So construct plant close to the noisy area as well to avoid ecological sensitive area where possible, and to the co-location with the other energy system, as I explained to in solar energy system, as the more or less says. And in USA, 35 megawatt wind farm installation on a former steel production site. So that's the way we can reduce the land's footprint. Then what are the take-home messages after all this? So from the initial, we learn it's that's the what is the renewable energy can do, and then we also see that it has some negative effect. So this energy, that means solar and wind energy, are not free of adverse environmental consequences. And though these have a low greenhouse gas emission, land use, and all are abundant, land are abundant in nature. And the major environmental drawback are bird mortality, with then biodiversity and habitat loss, noise, especially for windmill, visual impact for wind, and hazardous chemicals for solar. Thank you.